So once you've learned all about limits, that leads you into the derivative. So let's take a look at the derivative when looking at graphs and a couple calculations. So our first one is taking a look at the limit and what it is. And what defining derivative, and the derivative is a limit. So it's now just a new term we're using when we're describing the slopes, the tangents, so the tangent line that's hitting our curves, or rates of change. One type of notation you can see is dy over dx. That's one way to show your derivative, but we're still using that same formula that we learned when we saw limits. We also know that the slope is going to be that formula, and the only other way you can see it sometimes is you'll have f prime, meaning your first derivative, but using that same formula. So when we're looking at that, what we want to start with, and this will lead us into some graphs, is that we want to show that the function f of x is equaling the absolute value of x is not differentiable at 0, meaning that there is no derivative at the 0. So to do that, what we want to do here is use our formula. So f prime, or the derivative at 0, is going to equal our limit as h still tends towards 0 of f of 0 plus h, so just plugging in that x value, plus f of 0 all over h. Now this will just simplify to the limit as h tends towards 0 of f of h, and then f of 0 is just 0, so we don't have to write anything down there, all over h, which ends up being the limit as h tends towards 0, now that we just plug it in, of the absolute value of h over h. So this is our first part, and we can't directly plug in 0 because we can't divide by 0. So what we can do is take a look at the limit as h tends towards 0 from the right. So if we're coming in from the right-hand side of 0, all our values would have been positive. So you would have a positive value of h over h, right? Same value. And anything divided by itself is just going to be that positive value of 1. Now we can think of the limit coming towards 0 from the left-hand side. So this time, if we're doing that, and it's from the left-hand side, we're going to have a negative value of h coming in all over h. And when you divide that, it's going to be -1. So when we're looking at the limits, because we get two different values, it's not going to be just one certain slope. It means that a point there doesn't exist. So if you took a look at this graph, it looks like this, right? We definitely can find slopes of the tangent line over here and over here, but at this point where it's that kink, there is no limit because we don't have a slope. So when we're looking at where you can have differentiable, it's anywhere there's no corners or no kinks. So if you see a corner or a kink on your line, you have values that don't exist, so you can't take a derivative at that point. So when we're looking at our first example, and I just filled a few things in here, right? This first one with a, we can take a look at our slope of our tangent line. We would know that it's a negative slope. Down here, slope would be 0 because it's horizontal, and then it's starting to increase to be positive, then 0, and so on. So when we want to look to see what graph would match what we're showing, the start needs to be negative, the end needs to be negative. So when we're taking a look at our graph here, it looks like it's going to be number 2 for that first one. Now, when I'm looking at the second graph, I see that I have those corners and kinks, so there's parts that I don't have values for. So that has to be the first one. And then this last one, you have your slope down here would be negative, right? Because you're decreasing. Slope over here is positive. So we have a negative slope, a positive value here, and then we see what's going on. So it looks like that one will end up being C. So that's looking at graphs. Now, the other part is now just to figure out the derivative if you're given a function. So we're still always going to be using that same notation. So in this case, if we want g prime at -1, we're still looking as your limit tends towards 0. So you would have that formula, this time instead of an h, it's a g, of a plus h minus g of a all over h. But we know that the a values are going to be -1. So we can write this out as g of 1 plus h over, or sorry, minus g of 1 all over h. So from here, we're going to plug in to our formula. So g of 1 over h is going to be 15 minus 3 times 1 plus h squared minus then g of, oh, this should be negative 1. I'm not writing in a negative. Negative 1 going in for that a value, g of negative 1. And now I don't want to write the g, I want to actually plug it in. So here we'd have g, I just did the same thing. I don't want to write the g, I'm plugging it in, minus 15 minus 3 times negative 1 squared. So that was the other part, and then this is all over h. So we want to expand this all out, and this first part where we'll have, I'm just going to expand this, multiply by 3, and then subtract it from 15. So this part will simplify to 15 minus 3 plus 6h minus 3h squared. And then on my right-hand side of the numerator, I will have minus 15 plus 3, and this is all over h. So I see some things canceling out nicely, and then I can factor out an h in the numerator, and I'm left with 6 minus 3h all over h. These h's cancel. Now if I plug in my limit of 0, this term will go away, and I get 6. So what this means is at that point, negative 1, and if we had in that value here, what would that be? Negative 12? If we plugged in negative 1 into this first part here, that would be my point. And at this point on this line, the tangent line will have a slope of 6. So lots of work there, but up next we're going to learn the power rule, which makes finding a derivative a lot easier. So definitely make sure you understand the graphs. If you are taking chemistry, please also check out my channel for lots of chem videos on Chem 30. And as always, thank you for watching.